Everyone, welcome back to my channel. In today's video we're going to dive into one of very important parts of data analysis, which is data visualization. So if we want, using for example iris dataset, to turn these values into meaningful or beautiful um, plots like box plot, bar plot, density and histogram plot, line and smooth and scatter plot, and even as a correlation matrix. So let's get started. We need only to, if we want to display a box plot, to use the ggplot. Before to write the command, we need to load this necessary packages and then write ggplot function from package ggplot2 and select the appropriate dataset file. In our instance is iris, aesthetic graphical, and select the grouping variable species with uppercase of C species, and while taking an example for petal width as a dependent variable or response variable, we can use color equal to species, then plus geom box plot. So this figure shows a distribution of each group on the dependent variable, or also called response variable petal width. When we can switch, for example, use color or fill instead to use color. I think using the fill argument is more better than the first one, which is color. So this is the box plot showing, for example, of each group, the minimum, maximum, median, first quartile, and the third one. And we can add on also the mean of each group on this dependent variable. Moving now to the second type, or second plot, which is bar plot. We can copy this comment and paste it here without using geom box plot. We must select geom bar, then start equal to, between double quotation marks, identity, and click to run. No, identity, my bad. So this bar plot, you display the, not the value or the mean, display the value of the cumulative, yes, value of each group on this petal width, the cumulative also of versicolor on petal width, and the same case of virginica. If we want, for example, to represent or display the value, for example, of mean or median, minimum, maximum, we should, or we must, substitute identity with summary and add fun equal to, for example, mean. In this case, this value refers to the mean of petal width on Setosa group, and this one for versicolor, and this one for virginica. The same case for the other metric like median, for example, median. So instead, we need to only substitute this argument, or this, for example, instead to use mean, we might need to use, for example, median or mean for the case of minimum. Also maximum, for example, standard deviation, SD. This figure refers to the standard deviation of each group on the dependent variable or response variable petal width. Moving now to the third one, which is geom density or density plot. Density. We need only to select one dependent variable, for example, petal width here. So this density refers to the concentration of or the probability of, for example, in this case, the probability of concentration of our data is 0.25 for this value 1. So the density explain the probability or the concentration of data for each value of petal width. We can also add a color, I think. Let's see, color, species. Yes, this is also the density for each species for the dependent variable. And also we can't instead to use color. I think the argument of fill is more better. That's very good. So this the probability of or the concentration of data or data here is more than, for example, when the petal width for this group here, I think the CETOS IS, I think is 0.2 refers to the high you can describe as frequently values on our or repeated values in our data. Moving now to the other, the fourth one, which is the histogram plot. Histogram. The same case. We need to switch only one dependent variable on x-axis. This refers to the count or the frequency of seeing each value of petal width. So I think 0.2 is more frequently on our data, and also we can add fill, for example here, for each group, fill equal to species. Yes, like this one. Moving now to, I think, geom line. Geom line. I can draw geom line using geom underscore line, but we need to add two dependent variable, one for x-axis and another for y-axis, instead to put the grouping variable or independent variable in the case of petal width, in the case of box plot and bar plot. So here, for example, we have sepal length L with uppercase, yes. So this line refers to, I think color is more here. Yes, this line refers to the, you can explain or describe the relationship between sepal length and petal width for each group. Red for setosa, green for versicolor, and finally one which is a blue one for virginica. We can also use, after geom line, I think geom smooth underscore smooth. So this refers the trend of relationship here and here and here between sepal length and sepal width of each group. The trend of this smooth line refers to the trend of relationship, and this band is the confidence interval confidence band of the relationship between the two dependent variables. For scatter plot, we can use scatter function from the car package. Yes. We have also loaded before scatter plot and put here the two dependent variables, sepal length, for example, length tilde petal width. Petal width is the first, I think, yes. Here. Very good. Okay, and remove this one. And then select the data, which is data equal to iris. The scatter plot is more attractive and meaningful because we have here the box plot showing the distribution of beta bits, here the box plot showing the distribution of simple length values. This solid line or straight line here indicate when the solid line lies within this band confidence, we can assume the linearity between these two dependent variables. So the linearity assumption is one of very important assumptions in a case of, for example, ANOVA, for many of tests for comparing between means, especially parametric test one, and also GLM test. The smooth line refers to the trend also of relationship between these two dependent variables. The finally plot refers to the matrix correlation matrix from GG-Ali package using only GG pairs. No, GG pairs, and select, for example, iris, and then as the graphical color what the grouping variable species with a simple command. We can draw and display the results of many of plots in only one, and also the results of correlation coefficient percent. So here refers to bar plot of the numbers of individuals on each group. This is the box plot of each group on the appropriate dependent variable. This the density plot that we have applied before. This the scatter plot, or the point here. We can add the point, I think, for example, in the case of geom line or geom smooth. Let's see then. Yes, smooth, for example, add plus geom point. See, very good. So we can draw the point refers to the relationship between these two variable, and also the smooth trend relationship between two dependent variable. So moving now to explain the thing with, yes, this one, the correlation matrix describe the correlation percent between each variables, or each two dependent variables, and also for each group here and here. We have here the box plot, the bar plot showing the numbers of individuals, the density plot, the scatter plot with each group, and the histogram plot. So finally, I think this is the end of today's video. We've successfully learned about several types of data visualization, including the box plot here, bar plot, density and the histogram plot, line plot, and smooth plot with point, the scatter plot, and finally the correlation matrices of correlation. If you found this video helpful, I will add also the command, this command for data visualization below in the comments of this video. Don't forget to like if you want the video, subscribe if you haven't already, and take good care of yourself, and peace out.